All right, hey AP Chemistry. Earlier today there were a couple of concerns and questions about doing calculations relating to energy and wavelength and the type of questions that would be asked. So I kind of reworded and made a little bit of a different question from earlier in class. So I have that the 3p electrons in aluminum require 0.58 megajoules per mole. And just as an aside, 1 megajoule is equal to 10 to the 6th joule, just like as a note. So 1 megajoule, meg is a million, is 10 to the 6th joule. It takes that much energy, 0.58 megajoules per mole, to remove. If I shine light of 385 nanometers on aluminum, will electrons be ejected? Or I'll say, will electrons be ejected from this 3p? So let's say, will electrons be ejected from the 3p? Okay, so how do I answer a question, or how do I relate wavelength and energy? This is a unit of wavelength in nanometers, and this is a unit of energy in megajoules per mole. How do I do that? There is one very important equation. E equals hc over lambda. We talked about this equation at the very beginning of our important notes. We had wavelength is equal to speed of light over frequency, or we had frequency is equal to speed of light over wavelength. We had those equations. If I plug and chug into an energy equation, I have E is equal to h nu. I could do h times the frequency, or I could do h times c over lambda. Now h is a constant. It's called Planck's constant. 6.626 times 10 to the minus 34th joules times second. C is the speed of light, 3.00 times 10 to the 8th meters per second. These are constants that are going to be given to you. The only thing you don't have or you're looking for is either the energy or the wavelength. So this problem gave me a wavelength, but wavelength, just like electromagnetic radiation, is an energy or compares to an energy. So I'm going to have to make these both the same unit. So I'm going to have to convert 385 nanometers into megajoules per mole and compare that to 0.58 megajoules per mole. All right, so in doing that, I'm going to plug and chug my numbers in. I have 6.626 times 10 to the minus 34th joules times second. Speed of light is 3.00 times 10 to the 8th meters per second. Now notice how my units of speed of light are meters per second, and my wavelength is in nanometers. I have to convert nanometers to meters. Nanometers to meters is dividing by 10 to the 9th. There is 10 to the 9th nanometers in 1 meter. If I do that, I will get a wavelength of 3.85 times 10 to the minus 7th meter. Prove to yourself that converting 385 nanometers to meters gives you this number. And now all I'm doing is plugging and chugging these values in to get an energy. I did it before, and I got an energy of 5.16 times 10 to the minus 19th. Now the units I get are joules. This is the unit I get. If I cross out meters with meters, per seconds with per seconds, okay, per seconds with seconds, I'm left with joule. I'm not near my megajoules per mole yet. I could convert this joules to megajoules if I wanted, or I could compute this joules into per mole. If it says per mole, remember that 1 mole is equal to 6.022 times 10 to the 23rd things. 1 mole of things is equal to 6.022 times 10 to the 23rd things. This is only joules for 1 electron. This energy is the joule for 1 electron. What would the energy be for a mole of electrons? Well, if I want to do that, I have to multiply by 6.022. 6.022 times 10 to the 23rd electrons for 1 mole of electrons. And this is the joule of 1 electron. If I do this math, I will be left with a per mole number. That number I get is, and I'll do it on the calculator, I get 3.1, I get 310,922. So that's 1, 2, 3, 4, 5, 3.11 times 10 to the 5th joules per mole. That's the value I get in joules per mole, okay? 1, 2, 3, yep. So now I'm close to this megajoules per mole. I have to convert joules per mole to megajoules per mole. If I want to do that, I could use this conversion up here. 1 megajoule is 10 to the 6th joules. So I could plug this in over here. I'll do it over here. 3.11 times 10 to the 5th joules per mole times 1 megajoule is 10 to the 6th joule. And the joules will cancel out, and I'll be left with megajoules per mole. If I do this correctly, I will get 0.311 megajoules per mole from the 385 wavelength, right? This is from 385 nanometers from wavelength. This is how I convert wavelength in nanometers to energies in megajoules per mole. Tomorrow you'll have to do kilojoules on your quiz. Do I have enough energy? Well, it takes 0.58 megajoules per mole, and I only have 0.311 megajoules per mole. No. Will electrons be ejected? No. Okay? So, this is how you do a question where you have to compare wavelength to energy and tell me whether or not you have enough. All you have to do is say, oh, I have 0.311, but it requires 0.58. That's not enough. I need about 0.27 more. All right, so that is a quick video on converting wavelength to energy. Use this to kind of help you on your quiz or your first checking for understanding when asked a question that's very similar to this. If you have any other questions or concerns, let me know.